Okay, so welcome to the Adventures in Learning podcast. I'm your host, Dr. Diane, and this week and next, I have a special co-host. I have Lynn Wareh Coles back on the show with me, and we are going to be talking all things cicada. This week's guest is the Indiana Jones of the insect world, Dr. Gene Kritsky, and he's here because Lynn discovered him and wanted us to talk to him. So Lynn, what are the things that made you want to invite Dr. K onto the show?
Well, first of all, I've been obsessed with cicadas since I was a little girl, growing up in Florida and catching them. But his interest, his research interest, is in the evolution and distribution of periodical cicadas. And so those are the ones that come out every 13 years or every 19 years or every 7 years. And if that wasn't enough, his expertise in that area, this professor is also interested in entomology of ancient Egypt and has done research in this area, and Charles Darwin's interest in insects. So just a real interesting natural history perspective and a volume of information about cicadas.
Well, let's bring him on. I can't wait to learn everything there is to know about cicadas as we get ready for this incredible convergence this year. We have a super special cicada treat for you today. We have Dr. Gene Kritsky with us, and he is the cicada expert. He is let me see if I've got this right, an archaeological entomologist. Did I get that right?
Well, I guess you could say, although I'm more a pure entomologist, but I've published books on ancient Egypt and have lived, in fact, I lived in Egypt for a full year.
Well, when I read that, I got to tell you, I was imagining Indiana Jones chasing after cicadas.
Well, in his case, I could see instead of being snakes, it'd be cicadas.
Yes, exactly. Well, we are so thrilled that you were able to take some time to talk to us today about cicadas and the convergence. And maybe let's just start with, why are cicadas special?
Well, we're talking primarily about the periodical cicadas. There are 3,400 species of cicadas in the world, of which there are 7 in the eastern US that are periodical cicadas. And they're called that because every 17 or 13 years, they come out in massive numbers. And that's in part to overwhelm their predators, so their predators can eat and eat and eat some more, get sick of them, and there's still millions left. And that phenomena was observed by the Pilgrims in 1634. And when there was a major study of the taxonomy of cicadas, the researcher decided there's something really magic about these insects. And so their official generic name is Magicicada.
I love that. They really are magical.
Me too.
They are a once in a generation phenomena for various parts of the eastern U.S. And they make memories for the little kids that 17 years later, which is almost a full generation. I had a woman back in 1987 call me, and she told me that she remembered vividly playing with her brother during the 1936 emergence of Brood 10. And a cicada landed on his nose, and she knocked it off with a baseball bat.
Oh no!
Breaking his nose. And so 17 years later, she has her own daughter. And she's taking her daughter out and telling her this story and talking about cicadas. 34 years later, she's got a granddaughter, taking the granddaughter, sharing the stories of cicadas. And I'm sad to say, I don't believe she's still with us anymore, but I'll hope the stories still are in the family.
I do too. Go ahead, Lynn.
I know one of the many activities on Cicada Safari is oral history and all different ways. One of the things we're trying to do and we want to ask you about is, how do we make this real to our students and to children, and how can they participate and how can they get involved? And even if they're not going to be where a periodic cicada comes out, they could be in Florida where cicadas come out every year. And what are some things that they could do to be involved?
Sure. Well, the first thing for people who don't live in the area, maybe your grandparents do it. I don't know. But the first thing people can do, even if they don't live in the region of Brood 13 or Brood 19, is to get the free app Cicada Safari, which is an app I helped develop. primarily for crowdsourcing periodical cicadas. And even though they won't have any periodical cicadas to monitor where they are, they can follow it live. Because as soon as somebody sees a periodical cicada and they take their iPhone or their Droid and they have their location services or GPS turned on and they take that picture, they hit this little paper airplane icon at the bottom, it sends it to the app. And we have right now real humans looking at these pictures to verify that it's a periodical cicada, although we are actively trying to find a sponsor for this to apply artificial intelligence to the identification, because in 2021 we received 561,000 plus photographs.
Wow.
And so
That's a lot of photos.
that's a lot of photos. We had a team of 22 people looking at photographs, and we got them done. We got them done within we tried to stay as close as we could on time, but there were days that we'd identify, review over 20,000 photographs in a day, only to have 32,000 submitted that day.
That's fascinating.
Wow.
So what are some other activities that students could get involved with besides taking pictures?
If they're not living in the area, if you go to cicadasafari.org, the website that supports, you can get the instructions on how to fold an origami cicada. Back in 2021, I think about 8,000 to 9,000 kids in Dayton, Ohio made origami cicadas. It's large enough to be its own emergence, if you will.
Wow.
I love that idea.
For the younger kids, we got a periodical cicada they can color. But if you are a little more computer savvy, you can get online to Chronicling America, which is a Library of Congress free site. They've been digitizing newspapers from 1777 all the way to 1963. And they can look up newspaper articles from going back in time. Pick a year for a particular brood.
Oh, that's cool.
And see what's there. But they got to remember, when they get back to the 19th century, into the 1800s, don't call them cicadas, call them locusts.
Right.
Because they were incorrectly called locusts up to that time. And by the late 1800s, there were a lot of people saying they really are cicadas, but they still called them locusts.
Well, one thing I think is fascinating about the science is it's been, 150 years ago when they were observed, but we're just, 150 years later, we're just starting to understand the periodic nature. And I mean, it's a lot of people, a lot of eyes observing, a lot of thought to that. And I admit to reading your book, which I recommend to anyone. Diane will put that up in the notes for the podcast. But cicadas, the handy mini reference here. I learned several things, and I thought I knew a lot. Cicadas being, the idea of cicadas being negative, that they predict war, they predict plague, that they harm trees, that they harm the environment. Could you talk a little bit about why that's not the case?
All that started, a lot of that information started from when they first emerged back in 1634 in Massachusetts with the Pilgrims. By 1715, when Brood 10 emerged in Philadelphia, and that's the oldest historic record of Brood 10. There's a Reverend Sandell wrote that these strange insects came out. The Swedes call them grasshopper, but the English call them locusts. And so that goes back even before that. In 1699, a man by the name of Paul Dudley, living in Massachusetts and observing Brood 11, he didn't know what to make of these things, and so he asked a friend of his, Reverend Weld, who turned to the King James Version of the Bible to figure out what they were, and of course, they knew the indigenous populations in New England were eating cicadas. John the Baptist ate locusts. They came out in these insects come out in big numbers as periodical cicadas, and there were plagues of locusts in Exodus. And so they started putting together all these little pieces. So therefore they must be locusts. And that's where the name came from, as an effort to understand what was going on. Interestingly enough, when Paul Dudley wrote up his findings. And in 1699, he experienced emergence. 1716, he experienced it again. And then he waited another 17 years to make sure he was right. To make sure. And so he wrote this paper up and sent it to the Royal Society in London. And they got, while his paper was being read, people started objecting, saying he has confused cicadas for locusts. So rather than immediately publishing the paper, they wrote him a letter. And he said, oh, no, I've got this on firm authority. I've seen a transcript of this letter. I've got this on firm authority that these are locusts from Reverend Weld. So what the Royal Society did was they arranged for some Egyptian locusts in Cairo to be mailed to Paul Dudley in Massachusetts in 1734.
That's wow.
They got there.
That's even more amazing.
More amazing. And
they were not the same.
He wrote back and he said, you are right. I have mixed up locusts for cicadas, but then said, I don't think you'll ever excuse the fact that the common man here in North America is going to continue to call them locusts.
Sure.
And they did for another couple hundred years. And then finally, I'd say in the 20th century, starting in the in the middle of the century, especially with the work of the United States Department of Agriculture, we really got the word across that these were not locusts. And I think the last time somebody referred to them as locusts, I won't name the university because I like the university. It's not one I attended, but they referred to cicadas as relatives of crickets.
Oh no!
Oh no!
They're not. Cicadas are more closely related to aphids than they are to crickets.
Right.
So
interesting. So my understanding growing up was that periodical cicadas were native to North America, but I just read in your book that there are some in other places in the world. Is that a relatively new discovery?
It's been in the last 20, 30 years or so, but even though there are periodical cicadas elsewhere, they're not in the cicada family. They're not even closely related to our cicadas.
Okay.
So the magic cicada, the periodical cicadas that we have are endemic or unique to the eastern United States. They're as unique to the eastern US as giraffes are to Africa.
Excellent.
And the other two cicadas, one's in Fiji, it has an 8-year life cycle. And the other one is in India, and it has a 4-year life cycle. And until COVID, that always emerged at the same time as the World Cup. So the World Cup cicada, but they delayed the World Cup a year because of the COVID pandemic. So now it's out of sync with. But they don't remember it. They look very different from our cicadas. They're in a totally different genus and not even closely related at all.
Okay.
But
so we still have the
they're in the family Cicadidae. So they
Gotcha.
look like a cicada, but the coloration is very different. The life cycle is very different and so on.
So we wanted to take our own North American safari and go see as close as we could to this double brood emergence. Where and when should we travel to go?
Well, where and when it's going to the first, if you want to start with chronologically, they will start emerging probably the last week of April in northern Georgia, northern Alabama, northern Mississippi, and northern Louisiana. Then and of course the trigger for that is the soil must get to 64 degrees Fahrenheit. And just when that hits doesn't mean they're all going to come out that night. I've discovered in my 50 years working on cicadas that they really like a nice rain to sort of soften the world a little bit.
Sure, and makes it easier.
It makes it a lot easier. That's where you start with late. And of course, we're having a very warm spring here in the Midwest, and we had a warm spring here in 2021, and the cicadas still came out in mid-May, right outside the window where I'm sitting. In fact, but as the spring progresses and it warms up and the summer and summer's approaching, the first week of May, you'll probably see them around southern Tennessee and in Tennessee, probably from Nashville over through Chattanooga and what have you. Then as you go into the second week of May, they'll probably start emerging in Kentucky and parts of Arkansas, northern Arkansas, and then southern Missouri probably. By the third week in May, they should be coming out in good numbers in southern Illinois, southern Missouri. In the east side, there's a band through the middle of North Carolina and a few pockets of them in Virginia. But now we're into towards approaching the end of May, and you're going to see them coming out northern Illinois, the greater Chicago area, and then probably shortly thereafter it'll be southern Wisconsin and eastern Iowa as well.
All right.
So, excellent.
So that's when. Where?
Yes.
So the where depends on where you are in the world, and if you have cicada safari. If you have cicada safari, you can watch the map live as people report. Right. Their things are verified, their photos are verified. You'll see these little cicada icons popping up all over the map, and you can actually zoom in and get right down to the street. And that's how we tested Cicada Safari. We had it ready for brood 8 and brood 9. And so using Cicada Safari, we drove to eastern Ohio and western Pennsylvania and northern West Virginia. And we had streets, and we drove right to that street. That was what we did with brood 8. Brood 9, we went down to North Carolina and we picked out spots like, okay, well, let's check here. And they were there. And what was interesting about the year 2020 was that in addition to brood 9, we had 4 other broods emerge off cycle in very small numbers. But one of them was in Raleigh-Durham, which was a 4-year early brood 19 cicada. And we had records of where they were, and we got there. We didn't hear anything. We didn't see any adult cicadas, but we found all the skins.
Right.
Because all the adults were eaten by predators.
Right, because there weren't enough.
And so with that knowledge, you can actually follow where. And so depending on where you are in the world, if you are close to one of these states or what have you on the outside, you can then monitor when's the best time for me to drive the shortest distance to see these. And you can zero it pretty quickly. That was very different than what I had to do back in 1976 when I first mapped out brood 23 in Illinois. You would drive and not hear. Then all of a sudden you've heard them, and so you stop and then you drive some more, and you can actually pick them up at 60 miles an hour and know when to stop. But you were just basically driving blind until you heard the calls.
Well, there's all kinds of ways
such an adventure. Absolutely. So I have a question for you. How did you fall in love with cicadas and other insects? What drew you to that field?
Okay, well, it's a little bit of a roundabout story, but it's something that I think I tell my students there's a lesson here for everybody. I started at Indiana University in Bloomington as a bioanthropology major, very interested in human evolution. And in my human paleontology course, and this is the 1972, so there's not a lot of fossils like we have now. We've got more stuff. So we had this, I remember holding these 2 skulls and saying to the professor, Paul Jameson, who is still alive, and I talk with him via email all the time. How do you know these aren't just the male and the female of each other, as opposed to 2 different species? And he starts going on about morphometric analysis, doing all these measurements, putting in a computer. And then he said, you might want to take an entomology class because that's where they're doing that study. That's where they're working that out. Didn't think anything of it. So I went to register for classes. And in those days, we would go into a big field house and collect computer cards of all the classes. And so the seniors registered first, then the freshmen, then the juniors, and then the sophomores. I was a sophomore, and then in the class there was a random cohort of what alphabetical letters go what, and the K's were the last of the last.
Oh.
And I walked up to the table. I remember saying this is one of those events when you look back on it, it changed your life. I said, I need 5 hours. Is there anything open? And this woman says to me, I'm sorry, all I have is entomology in the lab. And I thought, well, I might as well take it because it may fit my human evolution.
Yeah.
It was taught by Frank Young, who was the periodical cicada specialist in Indiana. And the second week of class, he starts talking about these periodical cicadas. And I changed my major that week.
Wow.
Love it.
And what I tell my students is, don't get upset when you don't get what you thought you wanted to have. It's the serendipity that can lead to your career. And so
Absolutely.
I just thought, oh, and I ended up being Frank's undergraduate teaching intern. I took entomology. I was a teaching assistant in parasitology. He and I have written a book together now in its third edition. He's passed away, sadly, many years ago. We wrote several papers together. It was weird because this is nice. He was a U.S. Army Medical Reserve. I was a long-haired guy anti-war, and we hit it off right from the beginning. And when he passed, I remember when he retired, I remember him calling me and said, I need your help. Can you come over and see me?" And so I drove to Bloomington from Cincinnati, and he said, "I want to give you my teaching library because I'm going to retire." And I thought, okay. That was 62 cartons of books.
Oh my.
But what hit me in his class was in talking about these insects, I realized that there could be a lot of historical records that might be important. And I'm a frustrated historian. I love human evolution. I love archaeology and antiquity, and so on. So I just sort of thought, I'll bet there's some data that you can get by looking at historical records. So, graduate from Indiana, I go to the University of Illinois, where I'm working with the Lou Stannard, who was the Illinois specialist on periodical cicadas. I didn't do my thesis on periodical cicadas. I did it on a relative, but I did, while I was there in his lab, map out brood 23. And in my spare time, I looked up for historical records. And by the time I graduated with my doctorate, I had over 7,000 historic records of periodical cicadas.
Wow.
Now, what do you do with this stuff? And then Steve Jobs comes to the rescue with the Macintosh. And somebody, I don't know who, came out with a computer program that was designed to be a marketing tool about where to put golf courses. And why I was interested in that software was it had a mapping program.
Oh, I see
So I
it
converted
now.
all my records to FIPSI codes, which is the way, and I could put them in here by year, and I could give the program, I could ask the program, all right, give me a map of all the records of these years. I would pick all the collective years for brood 1, brood 2, brood 3, and so on. And I was printing out these maps on dot matrix printers.
Creative, very creative.
And I saw patterns, and that's why my research focuses on distribution and the relationship of the broods to one another. And there's obvious patterns. For example, if you've got a location like we have here in Cincinnati where there's two broods, they're usually adjacent to each other and they're 4 years apart. And so you could see these patterns. And that's how I got hooked.
That's so cool.
And I do remember as a kid collecting a large stag beetle when I was growing up in Florida. I remember a feral colony of honeybees had made some honeycomb in a protected area in this tree, and I walked home, and the comb was all over the ground. Bees were flying all over the place. So I remember, I'm a nerd. I took my chemistry set test tubes, and I put pupae in these test tubes in a little rack, and watched them develop. And then I ended up taking some to my biology. I was in biology at my Beach Senior High School, and I took them in there, and Mrs. Ferguson, my biology teacher, asked if she could put them in the display windows. The next thing, my bees are in the window, and it just goes on from there. But anyway, so that's my interest in insects. I always had an interest in insects, but I'd say I was more interested in natural history. I loved insects. I loved fossils, that type of thing.
When I love the way you've brought them all together to create just an amazing career. It sounds like you're doing something that's your passion, and it comes through so clearly.
Well, I do enjoy it, and I have enjoyed it. I just retired back in June, but I'm still teaching. I'm still writing books. My 6-volume series I edited on the cultural history of insects was just published in January.
Ooh.
And that's a series of 6 volumes, each one divided by time: antiquity, Middle Ages, Renaissance, Enlightenment, Industrial Revolution, and modern. There's 8 chapters in each book, and the chapter subjects are the same for each book. So if you're interested in insects and art throughout human history, you can read chapter 8 in all 6 volumes. If you're interested in how insects influence the world of antiquity, you can read volume 1.
Wow. Well, I'm a nerd, so I know I'm running out to get that. And Lynn, don't bother, because I'm getting it for your birthday.
All right, Lynn, she must really like you because the 6 set sells for $550.
You'll be waiting.
One
You'll
at a
get
time.
one at a time.
One at a time.
So I'm curious, as you've been doing all of sort of your research and focused on cicadas, what is the single weirdest fact or single weirdest thing you've discovered about the cicada?
Well, I would know. Yeah, there are two things I'll put in there. One, because of my I was in 1999 at the National Entomology meetings. I predicted that the following year would be a 4-year acceleration of brood 10, and no one had ever done that before, and it happened. Massive numbers emerged in Cincinnati and in Washington and other places. Came out such numbers that they actually survived predation. They sang, they mated, they laid their eggs, and the eggs hatched. That was the first time that we've ever seen an off-cycle emergence survive. And that all happened because 9 years earlier, you got to be patient to study cicadas. 9 years earlier, I was teaching ecology, and I was also department chair. And I'm walking down the hall and I'm realizing I forgot I had a lab today, and I've not prepared anything. So, what's the first lab in any science course? It's the scientific method. So, I pulled out the paper by Monty Lloyd and Joanne White on comparing the growth rates of 7 and 13-year cicadas. I had the students read this paper. And I told them, I said, now, if you were to go to dig up cicadas today, and we were in a brood 10 to 17-year cicada area, 4 years after the eggs were laid, what stage should they be in? And I had them write that prediction on a piece of paper. They put it in an envelope. They sealed the envelope. They signed the seal. We put it in we put all them together in another envelope, tied it all up. Went down to the maintenance shed at the university, got shovels, and went over to the orchard to dig up cicadas. And they were bigger than they were supposed to be.
Interesting.
Oh,
It's exciting for the students too.
Well, of course, basically we make a prediction. All their predictions were wrong.
Right.
but
Science.
Monty Lloyd and John White said what they discovered was that in the first 5 years of life, 17-year cicadas only molt once underground, whereas 13-year cicadas molt twice. And they said if a 17-year cicada should molt an extra time in that first 5 years, they'll come out 4 years early. So we were going to test that. Telling your students in 1991 that in 9 years they're going to have early acceleration is like telling them don't smoke because you're going to get cancer. So we waited, and I continued digging them up every year to see their growth. And I felt confident enough after monitoring that they would come out 4 years early, and they did. Then their second question is, will they stay 13-year cicadas or shift back to 17 years?
Yeah.
So what do you think we should do about that? How would you determine that?
would you continue to track and monitor and dig up cicadas as you make your prediction?
You could, but the real prediction is when they come out.
Right.
So what you do is you wait 13 years.
13 years.
You're very, very patient.
Oh yeah, if I worked on fruit flies, I'd have this all solved in a month. But no. So 13 years later, a few hundred came out. I actually watched them come out, but not enough to overwhelm predators. They all got eaten. We never heard a single one at the emergence site. We found isolated wings and skins, but no adults singing or mating. 4 years later, massive numbers come out.
Oh, wow.
And they're joined by more accelerating cicadas, I think, from brood 10. And the net result now we've got, instead of having in the year 2000, I had 5 locations where we had matings, singing, mating, and egg laying. Now we had 33 locations.
Wow.
And they not only came out here, they came out in Baltimore and Washington and Indianapolis and Louisville, in addition to Cincinnati. And so clearly what happens is they come out 4 years early and they shift back to 17.
Interesting.
That is interesting.
And so what we've actually now seen, since we have 2 of these, we've actually now seen the origin of a new brood.
Yeah.
They'll be brood 6 by designation coming out in greater Cincinnati.
That was something I didn't know about until I read this book, that there could be, just as broods can go extinct, there can be new broods as well.
And right. And all this I was just described, except it's just the first generation. Brood 13 came out in Chicago in the year 2020, 4 years early singing and mating and laying. So they're on the verge of seeing a possible brood 9 coming out in the future.
Wow.
So that was the one thing that we say, what's the weirdest? The one that I'm really most proud of is the man that wrote that paper with his wife, Joanne, Monty Lloyd, was a good friend, passed away. And I was asked to give a memorial lecture at the University of Chicago, where he taught for years. And while I was there, I got an email from somebody in Northern Kentucky saying, I've got periodical cicadas this year. And I thought, they're not supposed to be there.
Yeah.
So I inquired, do they have red eyes? Oh, yeah, they do. So I came back from Chicago and went out and checked, and sure enough, they were periodical cicadas. And there was no brood expected in that part of Northern Kentucky and Western Ohio for the year 2001. So then I remembered that in 1988, a year after brood 10 emerged, there were a lot of cicadas that came out around Cincinnati and Northern Kentucky. And they came out after what I thought after 18 years, because Monty Lloyd, the same individual, had written a paper with John White saying 17-year cicadas emerging after 18 years. So this is the same. This really establishes it. Didn't think anything of it. So now it's 2001 and it happens again. And I started thinking, wait a second. 88, 2001, that's 13 years. Okay. 88, started going back, that's 75. That's the paper that Monty Lloyd talked about coming out for 18 years and just like less than 50 miles away. So then I want to have 4 consecutive emergences to prove that it's a 13-year cicada.
Right.
So I went looking and I found some of the records for the Malhalakan Dam in 1962. They had to shut down construction for a couple of days to, quote, clean the locusts off the rig.
That's great.
No. So now we have an established 13-year brood of cicadas in Southwest Ohio and Northern Kentucky, Southwest Ohio in particular, which meant there are 3 new species records for the state of Ohio. And very few of my colleagues believe me. So what do you do to prove it? You wait 13 more years. And in 2014, they come out in massive numbers again, all 3 species. And it's clear that they are 13-year cicadas because there's one cicada species that has a very unique coloration on the underside of its abdomen, Magicicada tridecim, and they were there.
Yeah.
And so literally to be able to discover a misidentified brood, and what had happened was it came out simultaneously with brood 14 in 1923. It came out 13 years later with brood 10, both of which occur in Southwest Ohio. So they just were reassigned there. And then nobody did any follow-up after World War II. And so they had just been assumed to be part of broods 10 and brood 14. And to be able to find that shows there's still a lot of really fundamental stuff you can still find.
That's really
I love it.
neat.
There's a whole way to explore, a whole horizon to explore with this. So
do you have any more questions, Lynn?
no, I'm good.
Well,
there is a
go ahead.
quiz. There is a quiz coming.
Oh no.
All right. What's the quiz?
I'm a college professor. There's got to be a quiz.
There's always got to be a quiz. All right. Well, college professor, give us your quiz.
No, you want to, okay. You want a quiz? Let's go for it.
Let's go for it.
I can be really, really persnickety
Uh-oh.
and ask detailed questions like where they should be coming out. But let's do something a little more. Can cicadas get sick? They get diseases?
Oh, that's a great question.
I would imagine
Yes.
the answer is yes.
Yes.
And
Yes.
you
And they can get a fungus that leaves a white chalky
that's right.
mass
There you
in
go.
their
Lynn, you
abdomen.
read the book. That's excellent. Yes. And that fungus, mesospore fungus, affects these cicadas. We don't know how they come up with they get inoculate the first time, but we do have circumstantial evidence that it's sexually transmitted. But how do the nymphs get infected the first time? That's what we don't know yet.
Does that only affect periodical cicadas?
No, there are similar fungi that affect the annual cicadas as well.
Okay.
But apparently can lay dormant in the soil for 17 years, the spores.
Mm-hmm.
And so what happens the infected cicada. Now this doesn't have, they don't come out fully infected. Usually it's late in this in the emergent cycle, probably the 4th week they've been out. You'll start seeing cicadas with their tips of their abdomen all sort of white between the segments, and then their butt falls off.
Yeah.
And it hypersexualizes these. This is where it's become R-rated now.
You'll edit this part out, Diane.
If
No,
there's a
keep
male
going.
cicada, if there's a male cicada in the tree and he starts singing for a mate, an infected male cicada will flick its wings like it's a female,
Oh, wow.
luring in the amorous male, basically to inoculate
Plus
him
transmitting the fungus.
and transmit the fungus.
Oh, wow.
Wow.
Cicadas are cool.
They are fun.
Well, the most interesting fact that I learned in your book was that the ovipositor, with the female laying eggs, is not only serrated, but reinforced with metals.
Yes. That was a
So-
project that I did with Matt Leonard at Kent State University Star Campus. There was a paper published about 20 years ago, I believe it was now, that had done some molecular analysis, chemical analyses of the ovipositors of wasps, ichneumon wasps, particularly that lay their eggs
yeah.
on trees.
I know those.
And they found that they were impregnated with metals. And so the observation is, I'll bet cicadas do that as well. So I tried to get some colleagues at Mount St. Joe to help me with that, but we didn't have the technology yet. But Matt was able to get his hands on an electron microscope that did elemental analysis, and so I went out and collected all 3 species of periodical cicadas and an annual cicada, and we sent them up there, and they did the chemical analysis. And sure enough, the ovipositors impregnated with metal. What's really interesting is the concentration of the metals are highest at the tip that actually does the sawing into the tree. So for the ovipositor, there's a central rod, and then there's 2 serrated blades that slide along the rod, cutting into the tree. And where they're serrated, there's more metal than there is at the base.
At the base. Interesting. That's fascinating. It's just fascinating. I'm a nerd too. What can I say?
Very good.
There's
Excellent.
nothing wrong with being a nerd. Well, Dr. K, thank you so much for being on the Adventures in Learning podcast. We appreciate your time, and we can't wait to send people to check out Cicada Safari.
Great. I welcome their help, and thank you for having me on.
Thank you. Take care. Wow. Dr. K was everything you promised and more. So what were some of your big takeaways from today?
Well, you've got to be patient if you want to study cicadas. But at the same token, there's a way for everyone to get involved with this. And I highly recommend getting you to cicadasafari.org, which is the website he mentioned, and the Cicada Safari app on your phone. It's got a cute little cicada that takes off when you open it.
I can't wait to go travel. I've already planned in the back of my head where I'm going to go to look for cicadas.
So it's all, there's several things, citizen science things you can do besides documenting the cicadas. But on the website, there's an oral history piece with some questions. Do you know someone? Does your grandmother live in Ohio? Do you know someone that might have seen one of these emergences? They're collecting the oral histories. I think Dr. Kritsky mentioned the origami. There's a coloring page. There's also a cool project after the cicadas emerge. And I've actually seen this done with abandoned anthills as well, where you take plaster of Paris and you pour it into the holes, and you can study the structures. This is his book. You can study the structures of the cicada burrows after they emerge.
Right.
They
have to be long gone, folks.
Yes. There's directions. There's directions about how to do that as well, and some other activities, and tons of facts. Some of the facts we talked about today, but all kinds of facts about cicadas.
That is so cool. And next week, we're going to be going even deeper. This week, you got to get all the facts about cicadas. Next week, we're going to talk to some authors. We're going to learn about eating cicadas. There might be a little art involved. So you're going to want to tune back in. If you're not satisfied with all things cicadas, I promise we're not done yet. There's more to come, and a lot of really fun stuff. So tune in next week to the Adventures in Learning podcast, and we hope you enjoyed today's episode.